Hello everybody. Today we're going to talk about oblique triangles. And with oblique triangles we have two major tools to help solve those oblique triangles. That being the law of sines and the law of cosines. In this first couple of videos I'm going to be talking about the law of sines. Now the law of sines as we see it is the sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Now notice that's a given triangle ABC naturally, where the uppercase A, B, and C are the angles, lowercase are the sides. Now you're never going to use all three of these at the same time. You're only going to use two at a time. And it could be in any order. It could be the A's and B's, B's and C's, A's and C's, doesn't matter. Right? And basically you have to have what I call a matched pair in order to use law of sines. When I say matched pair, I mean you have or have solved for a given angle and its corresponding side. In other words, you may be given angle A and side A. And that's going to help determine which ones we use. So let's take a look at an example that's going to use that. If we look over here, and actually if we follow right along with the packet, the info packet for law of sines, it's number 1, is on the bottom of the page there. And in triangle ABC, keep in mind oblique triangles do not have a right angle, so we can't use SOHCAHTOA or Pythagorean theorem. But in triangle number 1, we have angle A is 62 degrees, angle B is 48 degrees, and side C is 52 centimeters. So just draw a generic triangle ABC, doesn't have to be to scale. Angle A is 62 degrees, B is 48 degrees, C is 52 centimeters. So what we have to solve for are angles C and sides A and B. Now all three angles of any triangle always add up to 180. So if you take the sum of 62 and 48, which is 110 degrees, from 180, that'll give you angle C, which is 70 degrees. Now we have to use calculating information. I know previously I said use given if possible. Technically we calculated angle C, but we have to use it to solve for the other components. So now that we have angle C and side C, that becomes our matched pair. In other words, we know we're going to be using the C's as far as the law of sines. Now what dictates the other ratio that we use is what we want to solve for. So say for instance we want to solve for side A, naturally we have to use the A's. So we're going to start off by using the sine of angle C over side C equals the sine of angle A over side A. And again, the C's because that's what we're given, the A's because we're solving for one of these two components. And this example we're going to be using the law of sines to solve for a side. So we plug in sine of 70 degrees over 52 is equal to the sine of 62 degrees, which is angle A, over side A, which we don't know. And remember, how do you solve ratios or solve proportions like this? You have to cross multiply. So if you take A times the sine of 70, that's what you get here, that will be equal to 52 times the sine of 62 degrees, which is what we have here. And since we're solving for A, right now it's being multiplied by the sine of 70. The opposite of multiplying by the sine of 70 is to divide by the sine of 70. And what you do to one side of an equation, you must do to the other. So those simply cancel out, and you're just left with A. And then over here you have 52 times the sine of 62, all divided by the sine of 70. And all you do is type that in your calculator. And if you're using graphing calculator, it's pretty easy. If you're not sure, you can always just put your entire numerator in parentheses and your entire denominator in parentheses. You don't necessarily have to in this case, but you can. But you'd have 52 times the sine. Now keep in mind, as soon as you type in sine, it'll give you an open parenthesis. Type in 62, make sure you close that parenthesis after the 62. Then divided by your sine of 70, hit enter, you should end up with 48.86 centimeters for side A. Now, we want to look for side B. We still have our matched pair of the C's, and technically we have a matched pair of the A's. But let's use the C's because it was less calculated information. So we have our C's, and since we're solving for side B, we naturally have to use the B's. So we have our sine of 70 over 52 is equal to the sine of angle B, which is 48 degrees, over side B. When you cross multiply, you'd have B times the sine of 70 is equal to 52 times the sine of 48. Since it's B times the sine of 70, we have to divide by the sine of 70 to get B by itself. And again, what you do to one side of an equation, you must do to the other. So those cancel out, and you're only left with B. And then you take 52 times the sine of 48 divided by the sine of 70. And remember to close off your parentheses after your angle of 48. You should end up with 41.12 centimeters, which is side B. So basically we use the law of sines to solve for two sides that were unknown in an oblique triangle. In the next video we're going to look at how to use law of sines to solve for an angle.